Good evening, students. So welcome back to our next session on the topic methods of differentiation. So we have already had 3 sessions on this particular topic of methods of differentiation. So this will be our 4th session, and most probably for methods of differentiation this will be the last session. But as of differentiation topic we'll be having few more. As I told you, after methods of differentiation we'll be going to learn the application part of it, as well as we'll be going to see the differentiability part. Right, so we'll just wait for a few more minutes so that remaining students should also come and join our class. So today's session will be in our app, I guess. So some of you are there in YouTube. I guess you just come back to our app so that if you have any questions, so I can answer there. So I'll just check how many of you are here. So can you just let me know how many of you are here? Okay, Siddharth, Tara and Arun. So what about the remaining? So I have seen few of you are YouTube. So please come back to our app so that we can follow up here if you have any queries, any questions. Okay, we'll just so as of now only 3 of you are here, Siddharth, Thara and Arun. So we'll just wait for 2 more minutes and then we'll just start with our today's session, methods of differentiation. So basically in our previous session we have actually spent a lot of time while solving the questions itself, isn't it? So it's actually for as I told you, for inverse trigonometric ratios also there will be lot to do practice, even for differentiation and integration. So these type of topics, they actually need a lot of practice. So while you are doing practice, you will be cope up with that kind of questions, what and all typical kinds of questions you can get, because these typical topics, they won't have much concepts actually. So they will be having a quite number of formulas and some standard identities. So only most of them will be some standard identities, some substitutions, some formulas. So these all will be there in our inverse trigonometric ratios, differentiation, as well as our integration. Some methods and concepts will be there, but when compared to other topics and all, it will be less, right? Okay. Yeah, some of you has joined. Okay. So I guess some of you are here. So we'll just start with our session. Remaining will join the class slowly. So if you have missed any part of it, so you can see the lecture after the recorded part. So there will be no issue. So we'll just have a quick overview of what and all topics we have covered till now and what we are going to focus on our today's session. So in the previous session, we have finished implicit function. So in our previous session, we focused on only this particular topic, that is differentiation of this implicit function, where we have learned what is the definition, like which function is called to be an implicit function and how we actually differentiate this particular implicit function. Right, so we have solved some 2-3 questions. So some of them are related to based upon our JEE level questions. So that's why we took a lot of time in our previous session to solve these typical questions in the context of our implicit function. So coming to our today's session, we'll be starting with parametric form. As I have already given a quick intro of what is parametric form and all in our previous session, I'll just go through it once. So basically, we'll be having our function in terms of other parameters. For example, it can be some theta, it can be some t, it can be anything. They'll be giving some condition, and our function, generally our function will be in terms of x variable, but here we won't be having our function in terms of x. So it will be having in terms of some parameter. For example, we can say theta is also parameter. So we can find our functions in terms of these typical parameters, right? So after that, we are going to see the next topic, that is differentiation of function with respect to another function. So till now, if you remember how we are doing this differentiation, so if we are having a function f of x that is equal to some x square, so we'll be taking that to be y is equal to x square, and we'll be differentiating this particular function with respect to the variable x, right? So here what we are doing, we are differentiating the function with the variable x, but here what we are doing, we are differentiating not with the variable but with respect to the complete function. For example, let us take two functions. F of x is one function and g of x is another function. So our differentiation is nothing but d of f of x with respect to d of g of x, which means we are differentiating our function f of x with respect to the complete function g of x. So till now, what and all we have covered in our methods of differentiation, in every perspective, in every method, what we have learned and what we have done, we have simply differentiated our function with respect to the variable x, isn't it? But here for this particular method, we will be differentiating one function with respect to the another function. So how can we do this, and how can we simply do this typical differentiation of one function with respect to the another, we will be going to see today. And after that, we will be getting into our next topic, that is differentiation of determinants. Right. So determinants, if we compare to our normal function, determinants will be different. Right. So if we are representing a function in terms of determinants, obviously the differentiation will be different. Because when we compare our function and a determinant, they will be having two different representations. They are different from each other. As the same way, the procedure of differentiation will also be different when we compare to our determinants as well as our regular functions. So here we are going to learn how to do the particular differentiation for any given determinants. And the last topic for our methods of differentiation and for today's session is nothing but successive differentiation. Right. So, if you remember in our previous sessions, I have discussed about the higher order derivatives. If you guys remember, there I have talked about first order derivative, second order derivative, third order derivative. So, likewise, we have gone till nth order derivative. Right. So, here our successive differentiation is nothing but doing the n number of derivatives. Right. So, how we'll be doing and all we'll be seeing as of today's session. So, these are the 4 topics which we are left in this methods of differentiation topic, and we are going to finish as of our today's session. So, let's begin with our today's session. So, if you have any questions, so please comment down there so that I can reach you as soon as possible. Right. So, to begin with our today's session, we'll be starting with the concept of parametric form. Right. So, here we'll just see first, first we'll just see the basic definition of it, and then we'll see how we actually differentiating that. Right. So, if we are having x and y are sometimes given as functions of single variable. So, generally in our differentiation, what we'll be doing? Dy by dx. So, our y is equal to some f of x function. But when it comes to a parametric form, for our x, we will be having a function in terms of a separate parameter variable, and similarly for y also we will be having a function in terms of the parameter. Right. So, here initial function will be y is equal to f of x, which means our y function is nothing but in terms of x. But here our both variables x and y will be having some different single functions in a variable. So, let me take a function variable, a function in terms of parameter t. So, let it be phi of t, here psi of t. Right. Or else we can say our x function is nothing but f of t and our y function is nothing but g of t. Right. So, these two are nothing but our functions in parametric form. So, in these typical cases, our x and y are nothing but called as our parametric functions. Right. So, because they are not given the functions in our regular variables, so instead of that, they have given our functions in terms of a particular variable, which is nothing but a parameter here. So, we call that as a parameter. Right. So, here we have got our x is equal to function f of t and our y is equal to function g of t, where t is a particular variable which we call it here as a parameter. And these two functions x and y are nothing but called as our parametric functions. So, now if you you guys are clear with what is actually a parametric function. Right. So, similarly, how we have learned first what is an implicit function, and then we have jumped into how to do the differentiation of that implicit function. So, we follow the same way here. So, first here we are learning what is actually a parametric function, and now we will be seeing how to differentiate this parametric function and find our dy by dx. Right. So, here you can observe. So, this is the example I just given. So, x and y are here our parametric functions with a variable with a parameter t. So, now let's see how we will be differentiating this parametric function, which means how we will be finding dy by dx. So, to find this dy by dx for our parametric functions, what we have to do? The relationship between x and y should be obtained by eliminating the parameter t. Isn't it? So here we are having our function x in terms of, for example, in terms of t, I am just taking t square. My y function is, let it be 2t. Right. So now here we have to find our derivative, that is nothing but dy by dx, isn't it? But here if you observe, we are having only the variables x and y. So if we want to find our dy by dx, we have to eliminate the other parameter here, that is other variable, that is nothing but t. So from these two, we have to eliminate the parameter t so that we could get our differentiation dy by dx. Then the question is how to eliminate this parameter. Right. So some cases what it will happen, it is not necessary, like it's necessary to eliminate the parameter, but in some situations what it will happen, it is not actually an easy way to eliminate the parameter. So if for example we are having some equations, by rearranging them we can easily eliminate, isn't it? But for some cases what it will happen, it is not very convenient to eliminate the parameter every time. So instead of doing that, what we can do is we can use a formula, that is nothing but our dy by dx is nothing but equal to, first here y function. So we will be differentiating the function y with respect to the parameter t, and divided by, we will be differentiating the function x with respect to the parameter t. So now if we rearrange this, dt will get cancelled, we end up having dy by dx. So if we follow this formula, it is convenient for us to eliminate the parameter, and it is easy for us to find the differentiation of the given parametric function. Right. So let's take an example and try to understand this in an easier way. So what I'll do, I'll take two parametric functions. For example, the same thing which we have taken earlier, t square, and the function y is equal to 2t. Right. So according to our formula of differentiation, dy by dx is nothing but to eliminate our parameter t. So what we are doing, dy with respect to t and function x with respect to t. So first our aim is to find dy by dt. So normal differentiation of this y function with respect to t, so it will be 2. Similarly dy by dx, which is equal to 2t. Right. So now here if we observe our dy by dt, it will be 2 by 2t, which is equal to 1 by t. So hence our dy by dx is nothing but equal to 1 by t. So you have to only remember the formula for these typical parametric functions, that is nothing but dy by dx is always equal to the differentiation of function y with respect to the parameter divided by the differentiation of the function x with respect to the parameter. So I have shown you one example here. So we'll just move ahead and let's solve a few questions so that you can understand this procedure in a easier way. Okay. So here they have given a question. So here if x is equal to cos cube t and y is equal to sin cube t. So here you are having x is equal to, one second. Akka. Delivery. Sorry guys. So here we are having a function x which is equal to cos cube t and a function y which is equal to sin cube t. So here what we have to find? We have to find the differentiation, that is dy by dx. Right. So here if you observe, our function x is given in a parameter t, that is cos cube t, and our function y is given in a parameter t which is equal to sin cube t. So here you have to find the differentiation, that is dy by dx. So please give it a try and let me know. So you can simply use our formula, that is dy by dt dx by dt. So those who have done, please let me know the answer. Yeah, Siddharth has given the answer minus tan t. Okay, Shyam also given the answer minus tan t, correct? So you have simply applied the formula and you have simply done your normal differentiation of the given function x in terms of t as well as the given function y in terms of t. So what about others? Only two of you have solved the question. Okay, Shivaranjani has also given the answer. Okay. So I'll just quickly write the solution here for you. So what is dy by dt? That is nothing but 3 cos square, sorry, first t, right? Sorry, y. So it will be 3 sine square t, and for sin x also we have to do the differentiation. So sin x differentiation is nothing but cos x. So it will be cos t. Same here. So 3 cos cube t, and for here cos x it will be minus sin t. So minus sin t. So 3 will get cancelled, and sorry, here's cos square. So one cos will get cancelled and one sin will get cancelled. We'll be remaining with minus sin t by cos t, which is equal to minus tan t. So for this given function, our dy by dx, the differentiation is nothing but equal to minus tan t. So I guess you guys are clear with this solution. Okay, Arun has kept a photo here. Okay, so dy by dx, dx by dt minus sin t. So why you got plus or minus? So it should be a multiplication, right, Arun? So it's not a plus or minus. So here in the denominator you have kept cos square t minus sin t. So it will be a multiplication, right? So when it will be a multiplication, in numerator also there are together multiplication. So then you have to, the terms will be getting cancelled and you will be remaining with only sin t in the numerator and cos t in the denominator. Okay, minus tan t is the correct answer. So I guess you guys are clear with this question. So we'll just move ahead for our next question. Yeah, so here is the next question. For the same typical methodology we can apply here. Yeah, okay, Aaron, got it, fine. So here there is the next question, but here you have to find value, right? So here they have given if x is equal to a secant square theta and y is equal to a tan cube theta, you have to not only find the expression for dy by dx, you have to find the value of dy by dx at your theta value is equal to pi by 8. So your first aim is to find the expression for dy by dx and then substitute your theta value, that is pi by 8, which is given here. So you might have not known this value of at the angle pi by 8, but in the tabular form of your trigonometric ratios, you will be having the values which you have to remember. So like you have seen 18 degrees, 36 degrees and all. So similarly, here you will be having the values of it that you have to check it. 3 by 2 tan theta, correct. How you will be finding the value of tan pi by 8? So it's a huge method. Like if you guys remember, in your 11th standard, I have taught you how to find the angle of 18 degrees. If you guys have remember, I have taken with 5a and we have solved. It's a huge methodology. So the same way how we have used the formulas there and solved it, we have to solve it here. And after differentiating, your dy by dx will be nothing but 3 by 2 tan theta. And in place of theta, you have to substitute the angle, that is pi by 8, and you have to remember the value. So no need to do this methodology and all, you have to simply remember the value, and tan pi by 8 value is nothing but equal to root 2 minus 1. So you can simply write this as 3 by 2 into root 2 minus 1. So if you go back to your 11th standard, there will be a formula sheet where you can find all these values where you have to remember. So you have to remember the values of not only the specific values like 30 degrees, 60 degrees, 90 and all. You have to even remember the values like 18 degrees, 36 degrees and this 45 by 2 degrees. And so these and all you have to remember. Yeah, Arun, correct. So I guess you guys are clear with this question also. So with this, I am sure that you are okay with this method of parametric form. So now we'll just move to the next part. So the next topic here, yeah, correct, 3 by 2 root 2 minus 1. Okay. So now we'll moving to our next concept, that is differentiation with respect to, that means one function with respect to the another function. So you can observe for this also the formula will be the same thing. Right. So what's the thing here? So we'll be having two functions. So let us take f of x. So let us take this to be some u function, and g of x, it will be v function. So we will be having two functions, but both will be in the same variable x. So now you have to find dy by, so du by dv. That means this function du with respect to the another function dv. So here we have to find differentiation of one function with respect to the other. So differentiation of function u with respect to the another function v. So the same thing here you have to, what you can do. So first you can differentiate u function with respect to the x variable, divided by you can differentiate v function with respect to the x variable. So dx will get cancelled. You end up having your du by dv. Right. So the only thing here is you will be having two functions u and v in terms of our variable x, f of x and g of x. So when we are doing with one function with respect to another, so generally what we will do, variable with respect to another variable, right? But here what we will be doing, one function, that is function u with respect to the v. Then it will be du by dx divided by dv by dx. So similar way, if we want to do the function dv with respect to du, then it will be the same thing, dv by dx divided by du by dx. Right. So I guess you got this formula how to do this differentiation of one function with respect to the another function. Right. So this implicit function, parametric form, and our, sorry, not implicit function, so it will be somewhat different. So parametric form and differentiating of one function with another, so they are actually following the same typical pattern of formula. Right. So the only thing you have to remember is what's the question they have asked for you, and with that related you can easily apply, write your formula, and you can simply find the differentiation for that corresponding function. So let's understand this while doing a question. So here they have given a question, differentiate sine square x with respect to e power cos x. So let's take your u function here is sine square x, and your v function is e power cos x. So you have to find differentiation of sine square x, that means differentiation of u function with respect to e power cos x, which means with respect to the v function. So simply apply the formula and let me know what's the answer. So it will be du by dx divided by dv by dx. So normal differentiation only, but here we are doing function with respect to the another function. So let me see, has anyone solved the question or not? Okay, minus cos x by e power cos x, correct? Okay, so that's correct, minus 2 cos x by e power cos x. What about others? Okay, Shyam, Arun also given the answer. Minus, okay, 2 cos x by e power cos x, anything fine, okay. Okay. So I guess most of you, all of you has solved this question. So your answer, that is this function of sine square x, when we differentiate with respect to e power cos x, the differentiation du by dv is nothing but equal to minus 2 cos x by e power cos x. I guess you guys are clear with this topic of differentiation of one function with respect to the other one. So now we'll move to our next concept, that is differentiation of determinants. Right. So there will be a separate procedure to do the differentiation for determinants. So what is that we'll be going to learn. Right. So to differentiate any determinant, so what we can do is we can take either one column or else a row. It's up to you. You want to go by rows, it's fine. If you want to go by columns, that's also it's fine. But whenever you are taking that, you have to take only one row at a time. Right, that means or else a one column at a time. Right. So if we are having a determinant, so the condition here to differentiate a determinant is we have to take a complete row or column at a time to differentiate, and the remaining will be kept unchanged. So let me take a easy determinant. So let us take a function f of x. So we'll just take a 2 by 2. So here some x variable again, let us take okay, let me take x square 1 x plus 3 and let it be 2x cube. So this is my determinant, that is nothing but my f of x function. So let's go by row wise. So now I am taking row, right, which means whenever I am taking, so when we are doing differentiation, I have to take a row or a column, a single row or a column at a time. So that only has to be differentiated and remaining has to be kept unchanged. So my f dash x will be equal to, so as I told you, I have taken row, so I have to differentiate this first row. So it will be 2x and differentiation of 1 will be 0, and the terms which are present in second row, they will be remained as it is. Right. So the next step will be plus. So in the second step, we will be taking the second row. And first row elements, they will be as it is. So it will be x square and 1. So we have to only differentiate the elements which are present in second row. That means here x and here 6x square. So if we add it, what we will be getting? X square plus 2x, and here it will be 1, and here it will be x square plus x plus 4. So here it will be 6x square plus 2x cube. So this is how we will be finding the differentiation of a determinant. So if we go by a row. So let's check what happens if we go by a column. So let me take the first column here, which means this one I have to differentiate. So it will be 2x, and then here it will be 1, and the remaining two terms will be remained as it is. So for the next one, I have to take my second column. So first column elements will remain as it is, and second column will be 1 differentiation will be 0, and here it will be 6x square. So we have to add these two, which means 2x plus x square, and here 1, and here x plus 4, here 2x cube plus 6x square. So now you can understand, even if you could go by a row or else if you want to go by a column, but it will be the same thing. But the only thing we have to remember is, whenever we are differentiating a determinant, we have to go by one single row at a time, and the remaining will be keeping others unchanged. Right. So I'll just show you that. So I have here, I just taken an example and shown you. So in terms of a function, we can find that here. So here you can see the function. So here this is our determinant, that is our function f of x, which is a 2 by 2 determinant having the elements f of x, g of x, u of x and v of x. So then our differentiation of this function f of x, if we go by row, then it will be, first step will be first row differentiated, so f dash x, g dash x, second row will be as it is, plus first row will be as it is and second row will be differentiated, that is u dash x, v dash x. So this if we go by row. Right, so what happens if we go by column? So then our first column will be differentiated first and the second column will be remained as it is. So f dash x and u dash x, g of x and v of x, plus, and in second step, second column will be differentiated and first column will be remain as it is, that is f of x and u of x, and second column after differentiation it will be g dash x and f dash x. So this is when we go by column. Right. So you can follow either of it. So if you want to go by row, then it's fine. If you want to go by column, that's also fine. So it's up to you. You can do any of the way and find the differentiation of given determinant. So here it's a general methodology, and here I have taken an example in the simplest form and just shown you the differentiation of determinant. So now let's do a question here in this regard of differentiation of determinants. So here is the question. So they have given a question in terms of theta. So f of x will be equal to, so here the function x, in terms of x only. So the function f of x is nothing but equal to secant theta tan square theta and 1 and secant theta tan x and x 1 tan x minus tan theta and 0. So here 0. So don't confuse here, the variable you have to differentiate is x and theta is nothing but a constant. So after differentiating with x, in place of x you have to substitute theta, that is nothing but you have to find your f dash theta. So try to find this and let me know whether you are getting the answer or not. So don't confuse with theta and x here. So here theta is just a normal constant and only our variable x will be there, because here the function they have given is in terms of x. So just solve it and let me know what's the answer here for this question. So that's what I'm saying. So don't confuse with theta and x. So whatever the variable will be given in this function, that only you have to take. Right. The remaining will be constants. So here they have, if they have given here the function is f of theta, then you can go with differentiating with respect to theta. But here they haven't given f of theta, they have given f of x. So the variable here is x and the remaining parameters will be constants. So here our theta will be a constant. So our theta term will be considered as constant and only our x terms will be considered as our variable here. So now I think you guys are clear with this. So now can you start solving this and find the value or else find the thing of f dash theta. So they have just given this to just give you a tricky view so that we actually get confused, right? So whether we have to differentiate with the term parameter theta or else the variable x. The first question will be that itself. And while we see this term of f dash x, we will be confused, right? We'll be confused. So that's why you have to observe what they have given function here, the variable, that will be correspondingly we have to differentiate that. Online payment hai kada? So I guess have you guys solved it? So what I'll do is I'll just show you the first step here so that you won't be confused with this theta and x terms. So to find f dash x, so I'll be going with row wise. I'm taking with respect to row. So first row I have to differentiate. So my differentiation here will start with secant theta. So secant theta here, my variable is x. So my theta will be a constant. So secant theta differentiation will be 0 and tan square theta also 0 and 1 also 0. And the remaining terms will be as it is. So tan x, 1 here, tan x minus tan theta and 0 here. So now you can do the second row and just follow it. Have you guys got it? Like the way of solving this question, or else if you have any doubts in this. I guess I have clarified your doubt, Shyam. So we'll just check it out whether you have got the answer or not. Okay, got it. Fine. Okay, Arun. So at last I'll just do it once. Then you can check the answer and solution with it. Okay, Shyam. Okay, good. So what about others, guys? Arun and Shyam has done it. Okay, Tara also got it. So I'll just quickly write the solution here. You guys can check. So for the second step, our first row will be. So for the second step, our first row will be remain as it is, and this will be differentiated. So this will be 0, and tan x will be secant square x. From here it will be 1, and remaining will be as it is. So plus our third step, so it will be first row will be as it is, tan square theta 1, and here secant theta and tan x and x, and here it will be 0 and tan x secant square x, and minus tan theta anyway 0 will be 0. So now you have to simply do your determinant. So for doing determinant, here all are 0. So this determinant will be anyway 0. But for here you have to find it. So here if we take secant theta, so this term will be 0. But here we'll be remaining with secant theta into tan x minus tan theta. Isn't it? So for tan x, this will be 0. And so minus tan square theta. So this term will be 0 and here it will be minus 1. So for 1 it will be 0 and so plus 1 into 0 and secant square theta. So similarly you can do this determinant and find the determinant value and you can simplify it further. Right. So now I think you guys are clear with how to do this differentiation of determinants. Give me a second guys, I'll be back. Sorry guys, sorry. Yeah, so here you can see it will be secant theta. So I'll just see your comments. Okay, Tara and Sham, Arun. Okay. So what about others? Shivaranjani and all? Have you guys got it? Because I am anyways doing the solution here. That's why. Okay, Siddharth also got it. Okay, so likewise you can just find it and your final answer f dash theta. Guys, give me 1 second. Green tea పెట్టాను నేను. So f dash theta will be equal to the final answer. Sorry guys, sorry. So here it will be tan square theta minus secant square theta. So that here you can see tan square theta minus secant square theta. So minus secant square theta into secant theta minus secant theta. So this will be your final answer. Can you guys look it over and let me know whether you got the same answer or else if you have any changes in that. If you have any doubts, please let me know. Or else if you guys are clear with it, please let me know so that we can move ahead with our next one. Please respond. You guys are okay with the solution? So I guess you guys are clear with it. So I think we can move ahead. So any questions here? Okay, you guys are clear. We'll just move ahead for our next topic, and that will be our last topic for our today's session as well as for the topic of methods of differentiation. So that is nothing but our successive differentiation. So what is actually this successive differentiation called? So if you guys remember, I have already told you like the first order, second order, third order. That is nothing but our successive differentiation of the function. Right. So if we are having a function which is y equal to f of x. So if we can differentiate that in one step, then that will be our first differentiation. If you can observe any x variable again after doing the first derivative, you can further differentiate it to reduce the x. then that will become the second derivative. So you can keep on doing that function differentiation until you can eliminate the variable x. Right. So likewise you can have first order differentiation, second, third, fourth, and it will go on until n. Right. So now let's take an example and understand this. So here I'll just take the function y equal to f of x, let it be 3x power 4. Right. So let's take the function that is 3x power 4. So if we are doing a general differentiation, so that will be our first order. So let me y dash or y1, I am differentiating with y1. So it will be 4 into 3, 12x cube. So if you observe, I am having a x term. So I can actually further differentiate it again. So now I am doing the second derivative y2 equal to 12 into 3 x square. That means 36x square. So now I am having one more x variable so that I can go on doing differentiation further. That will be my third derivative. So 36 into 2 into x. So that will be 72x. Here again I am having x term, so I can do it one more time. So y4 is equal to 72. So if I want to do the y5, then the differentiation of y5 will be 0. Which means for this given function f of x, that is 3 into x power 4, my first derivative is nothing but 12x cube, and my second derivative is 36x square, and my third derivative is 72x, my fourth derivative is 72, and my fifth derivative is 0. So I can't do further. If I do further, all the derivatives next will be zeros only, because anyways it's a 0. 0 is a constant. Right. So this typical ways of doing this differentiation one by one is nothing but our successive differentiation of the given function. Right. So let's read out the definition here. So if the first derivative dy by dx of a function is also a differentiable function, which means our dy by dx will also have a variable which we can actually differentiate it further. Right. So then it can be further differentiated with respect to x. So that's what we have done here. So we have taken our y is equal to 4x cube, I guess. Okay, 4x cube, and our y1 is 12x square. So here we can see we are having the x, so we can further differentiate it. Right, so that will be our second derivative, that is 24x. Right, so here I am having again, so my second derivative is also having the x term which can be further differentiable. So I will be having my third derivative, that is 24. Right, so if you could see, my third derivative can also differentiable further, which means my fourth derivative will be 0. So likewise, by following these successive steps of doing the differentiation for any given function is nothing but called as successive differentiation. So here we can represent that with some nth degree. So this dy by dx will be our first derivative, d square y by dx square will be our second derivative, d cube y by dx cube will be my third derivative, and so on, d power n y by dx power n. So if you guys remember, I have already shown these symbols, representation, everything in our previous sessions where we are talking about first derivative, second derivative, third derivative and all. Right. So this term actually denotes the nth derivative of our given function y. Right. So this typical process of doing the differentiation of the given function is nothing but called as the successive differentiation, and all these derivatives are nothing but called as the successive derivatives of the given function y. Right. So there is nothing difficult in this typical successive differentiation. It's nothing but simply keep on doing our differentiation until we end up having our differentiation 0, or else we can say our variable doesn't exist. Right. So this is about our successive differentiation of the given function y. Right, so with this, we have finished our concepts, all the concepts in our methods of differentiation. So we'll just wind up this class by solving one last question for our chapter, methods of differentiation. So here is the question which they have given. The function y is equal to secant 4x and t is equal to tan x. But here you have to prove dy by dt equal to 16t into 1 minus t power 4 into divided by 1 minus 6t square plus t power 4 whole square. So if you remember, understand here, if you observe here, we have to differentiate our y function with respect to the variable t. But here if you observe, our y function doesn't have a variable t. So now your aim is to convert your y function such a way that you will be having your tan terms here, and in place of tan terms you can substitute the t, so that you will be having your y function not in terms of x but in terms of the variable y, and then you can find the differentiation of that function y. So your first aim here is you are having y is equal to secant 4x, but here you have to convert this in terms of t. So just use your trigonometric identities to convert that and see what will be the answer here. So if you remember, we are having our formulas for in terms of tan 2x and sin 2x. So they are nothing but formula what we have, for cos 2x also we will be having a formula that is nothing but 1 plus tan square, I guess. So it will be, 1 minus. So 1 minus tan square x by 1 plus tan square x. And for sin 2x, I guess it will be 2 tan x by 1 plus tan square x, I guess. So these are the formulas for sin 2x and cos 2x in terms of tan. And even for tan 2x, we will be having, that is nothing but 2 tan x by 1 minus tan square x. So you can apply these formulas and convert the function y which they have given in terms of the variable x. And in further, after that, once you have converted your y function in terms of t, then you can easily do it. Okay, you want me to do that? So if you want, I'll just solve it, no issue. So I'll just do the differentiation here and simply add it. So here it will be, so these are the terms correct only, right? Yeah. So now after doing it will be, okay, I'll just write it again. So here this determinant will be anywhere 0 because 3 terms are 0. For here secant theta into secant square into x, 0 will be 0 and this will be 1 into tan x minus tan theta. So secant theta into tan x minus tan theta, and here minus tan square, it will be 0 minus 1. So you can directly say it as plus 1. And for here plus 1, so this term will be 0, 1 into 0 minus, so it will be minus secant square x. So this will be for the second part of derivative, which is secant theta tan x minus tan theta plus tan square x minus secant square x. So for this we can further find it. I'll be doing for this part of derivative. So I'll just erase it and do it so that it will be clear to you. So I'll just write the second part of derivative here. Second part of derivative will be secant theta tan square theta 1. Secant theta will be 0 and tan x will be secant square x, x will be 1 and this term will be as it is 0 plus third term, which means third row differentiation. So first two will be secant theta tan square theta 1, secant theta, tan x and x. Third will be 0 here, tan x, secant square x, and 0 will be 0. Okay. So now we have to find the determinant here. So secant theta into this and minus. So secant theta into this will be 0. So minus tan x into, so tan x minus tan theta. And minus tan square theta into 0 minus 1 plus 1 into 0 minus secant square theta. Right, so if we simplify it further, so it will become so anyways here we have to find f dash theta. So in place of x we can substitute theta, so it will become secant theta into minus tan theta plus tan theta plus tan square theta minus secant square theta. So these two terms will get cancelled. So anyways this will be 0, so this complete term will be eliminated. So from this particular determinant we will be remaining with tan square theta minus secant square theta alone. Right, so let's see for the second determinant here. So this will be secant theta into, this term will be 0, minus x into secant square x minus tan square theta into, this will be 0 into 0, so complete 0, plus 1 into secant square theta into secant theta, and this will be 0. So here in place of x we have to substitute theta because they have asked f dash theta. So this will become minus theta into secant cube theta, this will be 0, plus secant square theta into secant theta, that is nothing but secant cube theta. So our complete answer here will be tan square theta minus secant square theta minus theta secant cube theta plus secant cube theta. Right. So here if you want to take from these two, we can take secant square theta common and we can leave it as secant theta into secant theta, or else if you want to take common you can take it. So the final answer f dash theta will be equal to tan square theta minus secant square theta, one term. So I am taking here secant square theta common minus secant square theta, then it will be theta secant theta minus secant theta. So my tan square theta minus secant square theta is nothing but 1. Right, so here I can substitute 1, isn't it? So here you can substitute 1, so it will be 1 minus secant square theta into theta secant theta minus secant theta. So this will be the answer for the derivative question which I have solved here. So this will be the solution of it. So have you guys tried the last question here and let me know what's the answer. I'm not sure whether you have solved this question or not. So for this, as I told you, we have to convert this y function in terms of t. So our secant 4x can be written as cos 4x. So 1 by cos 4x, and we are having our formula for cos 2x in terms of tan, that is 1 minus tan square x by 1 plus tan square x. Okay. So we can write it as, replace that with, here it will be 1 minus tan square 2x and here 1 plus tan square 2x. Right, because for our cos 4x we are trying to replace that in terms of our tan. So now we have to replace this in terms of tan function, right? So our y function is nothing but 1 plus tan square 2x and 1 by 1 minus tan square 2x. So you can further reduce this by using tan 2x formula and try to convert that in terms of tan x, and just take this question as homework and give it a try. So we are running out of time. So just give it a try of this question. So I have started by converting secant into cos and then converting into tan 2x, but you have to convert in terms of tan. So you have to further convert it. So use your identities and convert this in terms of t and substitute in place of tan x t, and you can differentiate it. So this question, just take it as homework and try to solve it. And if you have any queries in this question, please let me know in our next session. Right. So with this, we are done with the chapter of methods of differentiation. So in the next, in our next session, we'll be starting with the application part of differentiation. So please try to solve this question and let me know if you have any queries in our next session. So we'll just start our applications of derivatives in our next session.